Some of your teachers might have told you the absolute value of a number is whatever it is as a positive. For example, -5, the absolute value of -5 is 5. And the absolute value of 5 is 5. In other words, whatever is in between these absolute value signs comes out as a positive. Now, I like to know why. Why do they always come out as a positive? And the answer is because the definition of absolute value means distance from 0. So if I were to have a number line and have a 0 here, and 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5, the answer is it's the distance. How far is 5 from 0? The absolute value is the distance from the number to 0, and it is 1, 2, 3, 4, 5 away. And how far away is -5 from 0? Well, it is 1, 2, 3, 4, 5 away. And that's why the absolute value is always seen as a positive. The answer is it's a distance from 0. And so this will help us understand some more advanced absolute value problems. For example, let's take a look at 3 basic problems, all at one time. The absolute value of an unknown number is equal to 1, and the absolute value of some unknown number is equal to 0, and the absolute value of some unknown number is equal to a -1. Let's start with this. If there's a 0 here, and the distance from x, the distance from 0 that x represents is 1 away, I could be 1 to the right, that's a 1, or 1 to the left, that's a -1. So, in other words, I can have a -1 in here, or I can have a +1 in here. So x will either equal a 1 or x will equal a -1. We could also write this as a number set such that x is going to equal a -1 or a 1. Number sets are written with brackets, not parentheses. What about this one? Absolute value of x equals 0. Well, in this case, we're talking about how far away from 0 is 0. Well, there is no distance. It's just plain 0. So in this case, x is just equal to 0. There is no such thing as a positive or -0. And our last issue is the absolute value of x is equal to -1. Well, distance can't be a negative length. There's no solution here. You can't be -1 away from something. We just don't do that. I understand the negatives are to the left and the positive to the right, but remember the definition is distance, and you can't have a negative distance. You have an absolute distance. So when you have an absolute value symbol all by itself with a variable inside and it equals a negative number, there just are no solutions to this. And if x, the absolute value here, and you have an equivalent of 0, you're just going to have one answer, because there's no distance from 0 when you're already at 0. And when you're at a positive integer, or positive real number, I should say, it is going to be 2 possible answers. And that's important to remember. Now, some people say, well, what about if it weren't just x there? For example, what if I had, well, let's say x minus 1 is equal to 0. Well, I need 0 in here. There's only going to be one answer. 0 equals 0. So x would have to be equal to 1. 1 minus 1 is 0. And the absolute value of 0 is 0. 0 is no distance from 0. So that's something to think about as we're solving these more advanced problems. When you have something with an absolute value buried inside an equation, it's best to go back to order of operations. The order of operations that you first learned, you learned your addition and your subtraction. In fact, in higher math, we see well, even in lower math, there is no difference between addition and subtraction. Here you're adding, and here you're just adding negative numbers, essentially. You don't do one before the other, you go from left to right. These are the same family. So you don't do addition before subtraction, you do what comes left to right. However, there's a higher order of operation. Repeated addition is known as multiplication, and to undo multiplication is division. In fact, division is just multiplying by a fraction. That's why you have a fraction symbol here, a number over a number. Then we have exponents. So you might have an exponent here. The way you undo exponents is with the radical symbol. These again are the same family. And then you have groupings. Groupings can be parentheses, they could be radicals, you have to do everything under the radical. Oh, the absolute value symbols are groupers, as are even division. You must group the top first before you divide by the bottom. So grouping symbols, what you may have remembered as parentheses, and maybe one of your elementary school teachers taught you something like PEMDAS, which I don't use because it's not parentheses only, it's all groupers. And we have a grouping right here in the absolute value. So that's the last thing we can touch. So what's the first thing we can do? When solving algebra, we do reverse order of operation. Is there anything I can add or subtract? And the answer is absolutely. I can take this -5, because this is 3 times a group minus 5. So I can add 5 to both sides. So 3 times a group of 4w minus 1, and the -5 and the 5 is 0, and 10 and 5 is 15. There's nothing I can add or subtract without breaking in the grouping. Some people ask, can they distribute? Yeah, you can. But we're not going to. I'm going to simply say, is there anything I can multiply or divide by? And the answer is, I can divide by a 3. So I'm going to divide both sides by a 3. 3 divided by 3 is 1. So I'm left with the group of 4w minus 1 equals 15 divided by 3, which is 5. I always want to isolate my group, and I have right here. Besides, it's the highest order of operations, and in solving algebra, I'm going reverse order of operations. There's nothing outside the group that I can add or subtract, multiply or divide, and I certainly can't use exponents or radicals at this time. I've now got the group. Now that I have 4w minus 1 in between the absolute value symbols, and it equals 5, as I told you, if your absolute value group is equal to a positive real number, there'll be 2 answers. You see, I don't care if inside here is a 5, and I don't care if inside here is a -5, because the absolute value of -5 is 5, and the absolute value of 5 is 5. So what I'm going to do is, I'm going to set this up where the stuff inside the absolute value can equal the 5, or the stuff inside here can equal the opposite, a -5. So now I start by solving both equations algebraically. Adding 1 to both sides. Oops. Adding 1 to both sides. 4w is equal to 6. Divide both sides by 4. And w equals 6/4. Simplified, w equals 3/2. Okay. Add 1. 4w is equal to a -4. Divide both sides by the 4. And w is equal to -1. We have 2 solutions. We have both -1 and 3/2. Our solution should be x is equal to either a -1 or 3/2. And, oops, I don't want to use parentheses. I want to use a bracket. Parentheses would indicate a coordinate pair on a graph. Now let's put in. Might as well plug them in. You can plug them in your head or do it more formally. 4 times negative 1 is negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is 5. 3 times 5 is 15. Minus 5 is 10. This works. We always want to test for what's known as extraneous solutions. Let's put the 3 halves in. I know it's a fraction. Don't worry about it. You can put it right in. 3 halves, and 4 is already over a 1. 4 times 3 is 12, and 12 divided by 2 is 6. 6 minus 1 is 5. 3 times 5 is 15. Besides, the absolute value of 5 is 5. 3 times 5 is 15, minus 5 is 10. Both these solutions I have verified is working. If one didn't work, I'd want to go back and check everything. And if it still didn't work, I want to know why wouldn't it work. It had to have a logical reason. And if it logically didn't work, we'd call it an extraneous solution. And we would not accept it. But I'm going to accept both here because they work. Okay, so let's try one that looks a little scarier. Order of operations from bottom to top. Anything I can add or subtract? Well, the answer is yeah. I can add a 7 to both sides. Negative 7 and 7, 0. So that's no longer part of the left side. 9 plus 7 is 16. I can't add or subtract anything because these are grouped. And outside the grouping is multiplication. So I'm going to divide. Division undoes multiplication. 4 divided by 4 is 1. 16 divided by 4 is 4. Now I've isolated my grouping. I don't care if there's a 4 in there or a negative 4. But the opposite of 4 is negative 4. And what's the opposite of less than? It would be a greater than. So not only do I want to set this up as 4 and negative 4, I also have to do the opposite of the inequality, which means that 2w plus 3 may in fact be less than 4. It also means that 2w plus 3 may be the exact opposite. So instead of less than, it'll be greater than or equal to. Instead of 4, it would be negative 4. I sometimes jokingly refer to this as is and the bizarro. So, as is and bizarro. This is the exact opposite. Instead of less than, it's greater than, equal to. Instead of 4, it would be a negative 4. And now I solve both of these problems. Well, w is being multiplied by 2, and then we're also adding by 3. So lowest order of operation, I start off with that. I'm subtracting, not multiplying by a negative, so I don't have to flip the signs. (2w) greater than or equal to negative 7. All I've got to do is divide by 2. So w is less than or equal to 1/2. And w here is greater than or equal to a negative 7 halves, or negative 3.5, to make things simpler. Before putting them back in, do I have an and or an or? Well, let's graph it and find out. If I graph this and I put 0 about here, and I put 1/2 about here, and negative 3.5 over here, I can then evaluate it. This side, it's less than or equal to. That's a solid dot. And less than is over this way. And this is going to be greater than or equal to. So it's a solid dot, and I'm going this way. They're going to join up in the middle. It's an and, which means everything between here and here should work. Anything outside should not work. I'd like to test this. I like to test this for a 0. And I'd also like to test it for a 1, which should be outside there and shouldn't work. I'd also like to test it for a -4, which shouldn't work. So that's my testing group. Something outside on the right, outside on the left, something in the middle to verify. Yeah, it's a little bit more work, but that's what the idea of mathematics is about. You may not always do math in your life, but you will have to test ideas out. So 1, 4, and 0. Let's see what we've got. So first, I expect this to work. I expect 1 to fail. I expect -4 to fail. Let's put a 0 in. 2 times 0 is 0 plus 3 is 3. 4 times 3 is 12. 12 minus 7 is 5. 5 is certainly less than 9. So yes, that worked. Now let's try 1. That should fail because it's outside our graph. 2 times 1 is 2 plus 3 is 5. Absolute value of 5 is 5. 5 times 4 is 20. And 20 minus 7 is 13. 13 is not less than 9. So as expected, it failed. -4. 2 times -4 is -8. -8 plus 3 is -5. The absolute value of -5 is 5. 4 times 5 is 20. 20 minus 7 is 13. 13 is not less than 9. And so, as expected, it failed. I'm feeling pretty good about my solutions. That W is less than or equal to half, and I can use the word "and" here because that's what that graph means. So, and my marker's not working well, and and W is greater than or equal to -3.5. I have found my solution. I have also found or drawn a graph. I have also tested my solution.